Alright, welcome back to review my channel, my underscore EXE. Today we're going to look at some problems involving the volume and surface area of prisms. So here's question 1. This figure shows a net of a solid. And this is most likely a prism because we're talking about the volume and surface area of prisms. So yeah. So for part A, we need to find the surface area of the solid formed by this net, and then we need to find the volume. For part A, which is we're asked to find the surface area, we're actually very lucky that the question gives us a better perspective of the solid itself. So it doesn't have some wonky 3D shape representation. Instead, it gives us the net. And when it gives us the net, we just need to calculate the total area of the net, which is then will be the surface area. And here is pretty easy to see that all of these squares are actually congruent to each other. So they are equal in size and equal in side lengths. So what that tells us is that we can just formalize our surface area as the number of squares times the area of one square. So let's see, there are 1, 2, 3, 4, 5, 6 squares, with each being have a area of 100 centimeters squared, which then will be 600 centimeters squared. So that's pretty easy. For part B, we need to find the volume of the solid formed by the net. And for that, we'll notice that each of these are squares. So what that tells us is its area is its side length squared. And since we're given an area of 100 centimeters squared, therefore the side lengths of each square will be square root of 10 centimeters squared will be just 10 centimeters. And notice if you fold this or wrap the solid, you actually get a cube. And perhaps the volume of a cube is pretty simple and is equal to its side length squared. Its side length cube in this case. So assume all of these side lengths are equal and is equal to s. Then this volume will be side length cube. And it's pretty easy to generalize this from the volume of a prism, which is the area of the base times the extension length, which will also give us s cube, where s is the side length. And in this case, our side length is 10 centimeters, so our volume will be 10 centimeters cube, which then will be 1000 centimeters cube. So question 1 is pretty simple. Let's jump into question 2. Alright, for question 2, it says that these figures below shows two different solids, which are cylinders, judging by its look. So we call them solids A and B. I should say cylinders A and B, since we know there are both cylinders, which has the same volume. Assuming x is positive, where x is this thing right there, find the value of x. And we need to express x in terms of m times square root of n, or perhaps I'll just rewrite that, m times square root of n, where m and n are positive constants and n is not divisible by any perfect square. So the square root of n cannot be further simplified, or at least it cannot extract any integer out of this square thingy. I hope that makes it clear. And also for part B, we need to find the surface area of each cylinders A and B. Alright, so let's do part A first. And we're given that their area are both the same. We can actually set up an equation in terms of x. And first, we'll probably just state that V of A, where V of A is the volume of cylinder A, equals V of B. And the volume of a cylinder is actually defined as pi r squared times h. And you can actually get this formula by generalizing it using the area of a prism. Alright, so we know our r can be replaced with x, which is our radius of our base, which is a circle, and our extension length is 10. While for cylinder B, we also have pi times r times pi r squared times h, where r is 5 in this case. So 5 squared, or it's 25, times our extension length, which is 30. Alright, so first notice that we can cancel out these pi's, and then we have 10x squared is equal to 750, and therefore dividing 10 on both sides, you get x squared is equal to 75, which means that x is equal to the square root of 75. And we can just simplify this by noticing that we can extract we can rewrite 75 as 3 times 25, and we know 25 is a perfect square, so we can extract that out of the square root. So we have 5 times square root of 3, which is our desired form in our question, which is m times square root of n. So that is it. And hence find the surface area of each solid. In the last video, we have generalized that the surface area of a cylinder, or perhaps I'll just draw this. So the surface area of a cylinder is defined as 2 pi r times r plus h. And if you're confused where did I get this formula, I would suggesting watching my previous video where I generalized some formulas for the volume and surface area of some prisms, including cylinders. Alright, so let's just do surface area of cylinder A. So I have 2 pi. We know that our r is x, and we just found x in the last question, which is 5 square root of 3. All that multiplied inside 5 square root of 3 plus our height, or I would say the extension length, is 10. Alright, and I'll just let you guys do the arithmetic here. You can either plug this into a calculator, or you can just plug in the value of pi, which is 3.14 or 22 over 7. So I'll just let you guys that's some arithmetic that you need to work there. While in the other hand, the surface area of cylinder B is 2 pi times our radius, which is 5 in this case, times all we have 5 plus our extension length over our height, which is 30. So thus we have 350 pi. And from here you can just either plug in the value of pi into a calculator, or use some approximations like 3.14 or 22 over 7 if you would prefer that. Alright, and that is it for second question. Let's jump into the third one. Alright, for question 3, we need to consider these 3 solids. Solid A is a cuboid or a rectangular prism with dimensions shown here. Solid B is a triangular prism with its base being a right angle triangle. Solid C is a cube with side length 2 centimeters as shown there. And we have 4 parts. 5 parts if you consider the 2 parts in D. So for part A, we need to find the maximum number of solid C's you can put inside solid A. Now when you face these types of problems, there is a formula to solve this. So the number of solid C's, I'll just call it N of C, is equal to the volume of solid A, which is the bigger volume, divided by the volume of one single solid C. So the volume of solid A, well, notice that is a cuboid with side angles 2 centimeters, 2 centimeters, and 10 centimeters. So that will be 2 times 2 times 10. And now extract the units at the front. And for the volume of solid C, notice it is a cube, so its volume will be 2 centimeters quantity cube. However, I'm just going to write this slightly differently, and you'll see why. And again, I'll just extract the units in the front because notice that we can cancel them. Well, notice that this 2 cancels with this 2 cancels with this 2 cancels with 10 with a remainder of 5. So therefore, the answer is 5. So you can put 5 solid C's inside solid A. For part B, we need to find the amount of solid A's you need to completely fill in a 2 meter times 2 meter times 2 meter tank. And notice that is a cubic tank. And again, using our formula before, so the number of solid A's, denoted as Na, will be the volume of the tank divided by the volume of a singular solid A. So that will be 2 meters times 2 meters times 2 meters as the volume of the tank, while the volume of a single solid A will be 2 centimeters times 2 centimeters times 10 centimeters. Alright, now be careful, we can't really cancel them because notice that we have different units here. And that is typically not a problem because we can just convert those each into centimeters. So each of these 2 meters will turn into 200 centimeters. And then after this, you can cancel up the centimeters as well as the numbers that match up here. So like I said, all the units cancel. Oops. And notice that this 2 cancels with this 200, leaving us with 100 there. This 2 cancels with this 200, again leaving us 100 on the top. This 10 cancels with this 200, leaving us with 20. So in total, there will be 200,000 solid A's, and that is a huge amount of solids. Alright, for solid C, part C, we need to find the amount of solid B's you need to completely fill in a 0.4 meters times 0.2 meters times 0.8 meters tank. So if N of B is equal to the volume of the tank given in the question C, all over the volume of a single solid B. Now the volume of the tank will be 0.4 meters times 0.2 meters times 0.8 meters. While the volume of solid B, and notice that is a triangular prism, and we can use that the fact it is the area of the base times the extension length. With this area of the base being a triangle, so its formula is half half times base times height. So for half times 4 times 5 given in the diagram in the question. There you go. While the length of this extension of the prism will be 20. And I'll put the units on the front. Like on part B, we cannot quite cancel some numbers because they all have different units. But don't worry, you can just turn these all into centimeters. Oops. This is supposed to be 20 centimeters. This is supposed to be 80. All over. So we have on the bottom we have 10. This whole becomes 10 times 20, which will become 200 centimeters cube. Notice that these units will cancel out, and notice we have some good, fancy cancellations. We can cancel this 40 with this 200, leaving us with a 5 on the bottom. Therefore, we can cancel this 5 with this 20, leaving us with a 4 on the top, and therefore we're left with a final answer of 320. Alright, for the first part of part D, we need to find the surface area of solid A. And you can just use the generalized formula for the surface area of a cuboid or a rectangular prism, or you can just use the form for a surface area that works in any prism. So that will be 2 times the base area plus the perimeter of the base times the extension length, and in this case it is h. So looking at the diagram, we can notice that we can actually choose multiple bases, and as long as your calculations are correct, you should end up with a same answer with a different base choice. I'll just choose this thing on the bottom there. And notice that that thing on the bottom is a square with side length 2 centimeters. So its area will be 2 centimeters squared, which is 4 centimeters cubed. Now the perimeter of this base, which is a square, will be 4 times its side length, which is 2 centimeters, which will be 8 centimeters, multiplied by its extension length, which is 10 centimeters. Overall, this will give us a surface area of 88 centimeters squared. Alright, so let's see. For the second part, we need to show with clear working that the surface area of solid A is less than the surface area of 5 solid C's combined. Well, since we already calculated the surface area of solid A, we only need to calculate the surface area of 5 solid C's. And what I mean by 5 solid C's, I meant 5 identical solid C's. And therefore, we don't really need to worry about those having different surface area. So we can write this as so. So 5 times the surface area of solid C. And on this, we can just use the generalized formula that I did in the last video for a surface area of a cube, which is 6 times its side length squared, which in this case will be 2 centimeters, and 2 centimeters squared will be 4 centimeters squared. And overall, this will give us 120 centimeters squared. And this indeed is greater than that. So we have done our proof. And that concludes this video. So hopefully you guys enjoyed this. Please subscribe for more videos, and I'll see you guys in the next one. Goodbye.